Hello friends, welcome to my new video. My name is Geoff and this is test-driven development screencast. Here we talk about test-driven development, evolutionary design, and good software development practices in general. This episode is continuation on the search functionality. We are going to continue where we stopped with the previous episode, and we had a bunch of refactorings in mind. This episode we're going to work on that. So let's see where we are. Um, Basically, here if we now let's see if the tests are green. Here, if we when we read these tests, when we see that we are passing a query to the searcher and we are getting some results. So we pass item, we get item 1 as a result, but the arrangement is missing. So what is the relation between this query and the actual results that we are getting back? So that's what we are going to focus on now. Basically, we have to we want to start working on. We have to push the hard-coded data that we have in the shipping code up the call stack, which means towards the tests. So we are going to end up only with abstractions there. But yeah, to start off with, first we want to on a high level, we want to also address the responsibilities of the searcher. Now, the searcher does here working on the query, it makes validation of the query and then does the search. So that's at least two responsibilities that the searcher is having. So we have to push somewhere these responsibilities as well. So where to begin is in the previous video, we wrote down here that the query is not generic enough. So we want to maybe first start with that one. So the problem is that now the query is treated as not valid only when we have it blank or we have it as an ABC. So we want to generalize that algorithm a little bit. And just to get a little bit more evidence, I'm gonna write one more test to make the evidence stronger, to get more evidence to where I wanna go. So I'll write another short query. Essentially, this is triangulation, and obviously I can triangulate forever working here in the query, but I think one more test is gonna make me at least more confident to towards where I'm leaning. So search state bad query would be the searcher result state, and that's gonna happen when I pass. So I would pass there, let's say, 3 blank spaces and AB. Essentially, this should be treated as an invalid query because the blank spaces should not be taken into consideration. So let's see. Let's watch this fail, and it fails. And in fact, if we look at the failure, we are expecting a bad query, but it treats the query as a valid one. So let's go ahead and fix that one. So we can start off by saying query stream length greater than 3. That should be a valid, or maybe is valid. So now I essentially didn't do anything, just introduce new variable there, and it should not. There is no consequence against the code that I wrote previously, so the failure is the same. But what I can do here, I can replace what I have in the if with not is valid and run. And that should work, I guess. And it does. So now what I can do, let's check this in first. Made the query validation algorithm more generic. Next step would be I would inline this one And in fact, I can also invert the if. Now I think I end up in a better position. Let's check this one as well. Inverted the if statement. So yeah, and now we can start working towards extracting a collaborator. So essentially, the approach that I'm taking is I know where I want to go. For example, now I want to push this the query validation responsibility into another collaborator, and so I know where I want to go. But the steps to get there, I want to split. Like I can make as small chunks as possible. So those small chunks of work are like you can call them nano or micro steps or baby steps or whatever you prefer. But essentially, I want to make as small steps as possible, and if I can make the IDE do those for me, I'm gonna be on a better. Whenever you have that ability, use that because it's always safer and faster. So I'm gonna do as little as possible steps that will make me feel more comfortable working on the code. So, and when the IDE does them, um, I feel suddenly I feel way better. So now we are still green, which is great. Um, so I can extract this into a function first. And yeah, so there is a refactoring which is available in Java called object parameter, I guess. But that's not available in Kotlin. Would have been great if we had that, so we can do this refactoring in one go. But because it's not available right now here, we have to do that manually. But it's not a big problem because as I said, we know where we want to go, but we want to split that in small steps. So I know all the steps that I want to do in order to get there. But the idea is that I won't do intermediate commits for those little steps. And then if I screw up something, it will be easier to revert back for me. So let's see how that's gonna go. So I'll introduce a class here. I'm gonna name it query validator. And I would put this function there. So now if I run, basically this shouldn't do anything, not involved anywhere, and essentially it shouldn't change anything. Cool. And now here, I can start using the collaborator instead. I mean, I can use the function inside the query validator instead of the function that I had before. Like that. And that should work, which is great. But the problem is that now on each invocation of the search, I'm making new query validator. And that's basically a logical duplication. That's not what we want. We want to make a collaborator out of the query validator and get that injected in the constructor as a constructor argument. But in order to be able to do that, I have to push this out, the whole class, essentially into another file. And we'll get back to this one just in a bit. I should be still green. Cool. And now this can become a constructor argument. Let's call this validator, right? And we can make it private and also do a little bit of formatting. And I should still green. Now this looks way better, and I can get rid of the function that I used to have before. That's I should be still green. Cool. Let's check this in. Extracted the query validation into a separate collaborator. Cool. Let's see here. We have a validate function, and I want to make explicit here the return type, and I want to also do it this way. I should be still green. Cool. Let's check this in. Improved code formatting. Now, the problem is this hard-coded number 3 here. So we want to push this up the call stack as well, because this is sort of a configuration. So now I'll run the tests to make sure that I'm green. And I'll make a defect injection. So what happens if I actually change this later on in production, say to 10? Because my query validation specification changed, let's say. This is gonna fail. And that's not okay, because I'll have to now go back and maintain all my tests that are failing. So that's not okay. So that's why I want to push this configuration up the call stack. And the way to do that is I can inject that one as a constructor argument as well. I'll call this min query length. Let's make that private as well, do the formatting. Now I'm in a way better position. Now, there is also another way to do that. Yeah, cool. And if I go back in my tests, in the setup, now I got the 3 coming. Actually, I pushed it up the call stack, so it is only relevant here now in the tests. I can make that more sort of obvious here by doing this. So let's check this in first. Oops. And I would say moved configuration data up the call stack. Yeah, so now let's talk about the other approaches that we can do. So for example, what I could have done here is I can do it now, in fact, but I'm gonna leave that as an exercise for you. So please let me know how that goes. So what we can do, we can extract an interface called, let's say, validator that will have the validate. And now the query validator will be my shipping code, but in my tests, I can come up with stubs. So let's say one stub would be a passing query validator that will return true whenever I call validate. And another would be, let's say, non-passing validator that will return false, obviously, when I on every invocation. And in that case, I can replace now in each test that I need, for example, passing validator, I'll use that the passing validator stub and vice versa for the non-passing. And obviously I will have to split these tests as well, because they don't belong to find one match test. And most probably that's going to be happening a bit further on, because now I still want to do the refactorings only in one file. But yeah, try it out and let me know how it works. And let's continue here. So now we also want to deal with this other data that is hard-coded. So essentially these values that we are searching, I'm imagining some sort of collection somewhere, and then I pass a query and all the items that are matching will be returned. I mean, in a long run. So I'm imagining now what is important for me. I'm imagining that collection of items somewhere, or of values somewhere. So I can start working in that direction. So let's see how actually we can deal with this. So let's create here a collection, and I will take this value, oops, and I'll assign this to variable, and I'll name it available values. So I didn't do anything essentially here. I'm just creating collection on each invocation. And now I can read this value that I'm getting here. I can read it from the collection. So let's say available values first that contains item, and I'll assign that to a variable that I'll name match. And that shouldn't do still anything as well. And now I can replace this one here with a match. That should still work. Again, I'm doing as little as possible steps here, and I'm trying to force the ID to do them for me, which is sort of safer. And now I could replace this data here. That's the query actually that comes in. So slowly I am replacing the hard-coded data with the abstractions. I'm still green, and if I take this one here and add it here, I should be still green. Good. And I can pull this one in this if, and that should be still green. So what so what I've actually done, I'm grouping the things together in order to. So I'm moving the sort of the details, the data. I'm moving to sort of grouping to one place, so I can actually then push it somewhere, like either to a obstacle stack, another collaborator, and so on. So basically now I can eliminate the else if. I cannot completely eliminate the if here, if and the else, but I can essentially eliminate the else. So that should still work, which is great. And now I can ask the actual list if it contains item sort of values that are matching. So something like let's say contains query, and that's gonna be oops. That's gonna be, let's name this has value. I just introduced new value here. I'm not using it. I should be still green. And here I can replace now this one with has value, and that should be still green. But essentially now I have only one place where I'm having the data, and everything else is sort of working with the abstractions that I'm having. I don't use any hard-coded data, which is great. Now I'm not very happy with this any and the first, and then having this duplication here, but the cool thing is that this is a duplication that I want to address. So I'm gonna address that sooner or later, but having this duplication will force me to work on that. That's great. So now let's check this in quickly to have a point where we can revert back. So we can say how do we name this? Moved, or let's maybe hard coded data. Yeah, group the hard coded data together. I don't know. Okay, and now let's maybe extract this. What I want to do is this. I want to get the result and then assign it to the value. So then I can decouple the search state live data value out of the actual result that is coming from the search. So let's first create a function here. And what I can do here, I cannot make the studio do this for me, but I can do something like result, and then I should be still green. I just get the result out of the search, and I don't do anything with it now. And now, in the last line, I can assign the value to the result. That should be still green. Cool. And now I can delete this. Yeah, I can delete this. And that should be still green. And I can also inline to make this a bit more clear. So that's cool. And I can extract another function out of this. Now name this form search, let's say. Let's make sure that we are still green. Although we are using all the time the IDE to do this refactoring, so we should be safe. I'll inline this one, and I'll also, let's run. It shouldn't do much, but yeah, still, it's better to check. And I can also inline this one. So now I think we are getting the search sort of pretty small and concise. And now this is something that we can start pushing somewhere. The idea is that I can inject the collection of items in the searcher, but the problem then would be that the collection of items is in a way lower abstraction level than the actual validator that I'm having. So I want to have the same abstraction level there. So essentially, what I'm thinking of is wrapping this list of this list into a class that I'm gonna own. So they are gonna be on the same abstraction level. So let's do that first instead of pushing this directly out from this class towards the tests. Let's maybe make a collaborator, something that we've done similar that we've done with a query validator. So I'm gonna come up with a class. We can name this inventory, or we can call this repository. Let's name it repository, more common in Android. And then I can do the same trick. Copy paste. That should still work. It does. And then here we can do the repository, perform search, and that should still work. So the idea is, again, introduce the new thing, do the replacement, and then delete the old thing. Cool. Now I can push this away, extract it into another class, and then we will come back to this one just in a bit. Let's make sure everything still works. Cool. And now this repository, we can inject it in the constructor. And we can make this private. that still works. And now I can, of course, blow away this guy here. Cool. Now let's check this in. Uh, let's maybe created. I don't know. Maybe let's make this commit more abstract. So push the search into a collaborator. Yeah. Now, as I said, let's get back here. And now, actually, we can push this one up the whole stack. So we can come up with constructor argument here. So I'm going to use the same name here. So let's make this private. Cool. It should be still green. It is. And I can delete this line here. And I think the actual repository is pretty okay. It's gonna evolve most probably when we will start working on boundary conditions like exceptional cases. And but first we are gonna start working with multiple items, like finding more than one item. When I search one query, it should return more values. And of course, I have to care about the exceptional situations, like handle exceptions and stuff like that, but that's gonna be happening in the next video. For this one, I think I'm gonna leave it as it is. But here in the tests, I think I'll make a little cleanup. So let's extract this one into repository and this one into available values. That should be still green. So we can slowly wrap up the episode because we are running a bit over 25 minutes, I guess. So then would be pushed data up the whole stack. Cool. Now the last thing that I want to do is actually expose the live data instead of the search state here, so we can take advantage of observing the live data and maybe use sort of property delegation, something like that. So first thing, I'll rename this into the private live data, which is a mutable here. So I can mutate inside here. It's private. And then I'm going to come up with search state live data. It's going to be live data type. And this one, because it's live data type, nobody can mutate. So the one that will access from outside, they won't be able to mutate it. And that's going to be equal to the private one. I didn't essentially do much. It should still work. But here I can use the new thing. And that should still work. And now I can inline this one. So whoever calls will use directly the live data, like so, which is great. That still work. And now I think the searcher is as clean as it can get. The only thing that might be added here is switching a thread when performing the search. Basically, we might introduce coroutines. Let's say if this searcher is view model or something, we can introduce coroutines and switch the thread, because if this is injected the searcher into a UI, the search will be called from the UI thread. We don't want to keep the searching in the UI thread. We want to switch the thread into background thread. So that's a little thing that might be happening here. But other than that, I think this cleaner now is as clean as it can get. It looks spotless to me. And I think that's how we are going to end up this episode. Um, let's check this in, and that would be post something like that. Yeah, so let's wrap this episode out because we are around 30 minutes. So actually what we managed to do is we pushed all the hard-coded data up the call stack. We have dealt with all of these things here that um, we had in mind, I think. And basically, this is the algorithm that we are gonna work to evolve. But what's next is like finding multiple items. We are gonna see how that's gonna work. But for now, I think everything is fine. So yeah, I wish you great holidays. We'll see. Most probably, I'm gonna continue recording and delivering new episodes during the holidays as well. But we'll see how that goes. I wish you all the best during the holidays. Please make sure to subscribe if you like this content. Give me some feedback. What do you think about these baby steps, the refactoring, and everything? And I'm gonna catch you in the next episode. Thank you so much. Stay safe. Cheers.